Hello guys, welcome back to this channel. On today's video we'll see about statical stability, determinacy and indeterminacy in structures. If you haven't subscribed to this channel before, please subscribe to support this channel. So let's start with determinacy. When we say structure is statically determinate structure, statically determinate structures are structures in which all the support reactions or the unknowns can be determined using only equilibrium equations. So we have three equilibrium equations. The summation of all forces acting on x is equal to 0. Summation of forces acting on y is equal to 0, and summation of all moments or rotations at a certain point is equal to 0. Let's see what statically determinate means by using the following example. We have this simply supported beam. Sorry. For this simply supported beam, we have reactions, 1 at the roller and 2 at the pin. These reactions prevent movement in the vertical and horizontal direction for a pin, and a roller prevents movement in the vertical direction. So we have a total of 3 reactions, and the number of equilibrium equations is 3. Since the number of equilibrium equations is equal to the support reaction, the structure is said to be statically determinate and stable. When we say stable, the structure supports prevent movement in any direction. What are unstable structures? Instability in structures occurs when there is either a fewer reactions or reactions less than 3, or the support reactions allow movements in structures. Let's see this example. You have a beam supported by 3 rollers. Before the application of the load, the structure is stable, and we have 3 equilibrium equations, and the support reactions are 3. We have 3 support reactions. But after the application of the load, the beam moves. Since this support does not prevent movement in the lateral or x directions, hence even though the structure is determinate, it is unstable. And if the structure is unstable, we should not construct it. What are statically indeterminate structures? Statically indeterminate structures are structures in which the support reactions or the unknowns cannot be determined using only equilibrium equations. We need extra additional equations known as compatibility equations to determine all the unknowns. Let's see the following example. You have a beam supported by 2 pins. So since pins prevent movement in the vertical and horizontal directions, we have 2 reactions at each pin, and we have a total of 4 support reactions. We have 4 support reactions. As always, the equilibrium equations is 3. Since the number of unknowns is greater than the number of knowns, additionally we need 1 extra equations to solve the unknowns, and in such case the structure is statically indeterminate. For statically indeterminate structures, we have to know the degree of indeterminacy, and the degree of indeterminacy is given by support reactions, which are the unknowns, minus the knowns, which are the equilibrium equations. And for this particular beam, the support reactions are 4 minus the equilibrium equations 3, which is equals to 1. So the degree of indeterminacy will be 1, or 1 additional equation is needed to solve all the unknowns. Examples. Classify each of these structures as stable, determinate and indeterminate structures. So on the left side of the screen you have a propped cantilever beam. On the right we have a fixed beam. Let's start with this propped cantilever beam. In case of this propped cantilever beam, we have a total of three support reactions for the structure to be statically determinate. Sorry. The support reaction must be equal to the equilibrium equations. Equilibrium equations, as always, are 3. The support reactions is equal to 3, and the structure is statically determinate as well as stable. For this fixed beam, we have a total of 6 support reactions. Remember that fixed supports prevent vertical motion, they prevent horizontal motion, as well as they prevent rotations. Hence, the support reactions must be equal to equilibrium equations for the structure to be statically determinate. But in our case, the support reactions are greater than the equilibrium equations, and the structure is statically indeterminate structure. So the degree of indeterminacy will be support reactions minus equilibrium equations, and 6 minus 3 will be equals to 3. Let's move on to another example. On the left side of the screen, you see a fixed beam, a beam which is fixed on one side and free on the other side. It is also supported by a series of 2 rollers. We have a total of 5 support reactions. Hence, the number of support reactions is greater than the equilibrium equations, and the structure is stable as well as statically indeterminate structure. The degree of indeterminacy will be 5 minus 3, which is equals to 2. On the right side of the screen, we have a similar type of fixed beam, but in this case, it is fixed at one end and is free to move on the other end. After considering the support reactions, we have 5 support reactions, but notice that these 2 rollers does not prevent movement in the lateral direction. Hence, after the application of the load, the structure moves. You can see that. Let's see it again. It moves. Hence, this structure is unstable structure. So this is how you classify structures as stable, unstable, determinate, and indeterminate structures. So if you have any questions, please leave it on the comment section below, and as always, subscribe to this channel. I'll see you in the next video. Thanks guys.